Today we're going to take a look at how we can use linear equations to model some real-world examples. These applications are word problems with linear equations. Word problems tend to be what scare students about math. They say they see word problems as if you had 4 pencils and 7 apples, how many pancakes fit in a roof? And the answer is purple because aliens don't wear hats. And that's about as much sense people see in word problems. However, I want to encourage you to see these word problems not as these abstract ideas, but actually useful ways to understand and model the real world. Now, we'll see equations. Linear equations look often something like y equals 3x plus 9. But both the numbers 3 and 9 have some important meaning in the problem that's going to help us with these problems. First, the 9. That number at the end that's added is the starting amount, however much we start with. And the 3 is the rate of change, how much it's changing by over time. Often you'll see this written as y equals mx plus b, where b is the starting amount and m is the rate of change, or how things are changing in the problem. So if we can identify how things are changing and stick that number in front of the x, and we can identify the starting amount and stick that number after the addition, we have an equation that can model the situation we're talking about. So for example, if we want to make an equation that starts at 12 and decreases at a rate of 4, we know that the starting number, it starts at 12, keeping in mind that y equals mx plus b. b is where we start, and m is how we change. So if it starts at 12 and decreases means it goes down, or we'll subtract, at a rate of 4. So y equals the change. It's going down, decreasing by 4, x, and it starts at 12. Add 12. This equation starts at 12 and decreases at a rate of 4. Now, usually word problems don't look like that. Usually word problems say you've got $250 in your savings account and you plan to save $50 per month. We're going to make an equation to model this and decide what each variable represents. So building our equation, we've got y equals the change. How is your savings account changing? Well, each month you are changing by $50 per month, and it's going up. It's actually increasing $50 a month. So we've got a positive 50 times x. That's how it's changing. It's going up by 50 every month. Plus, how much did we start with? Well, you started with $250 in your savings account. So y equals 50x plus 250 shows you how much money is in your account. So what does each variable represent? Well, we said that we get $50 more per month. So that number with the 50, that is the number of months that have gone by. So if we get $50 per month and we add 250, that's going to give us the total what? That's the total amount, number of dollars in savings. So now we know the total amount in the savings account modeled by this equation. Let's take a look at how we can use this. We've got a woman riding her bicycle at 22 miles per hour. She starts 3 miles from her house and she's riding away from her house. Remembering y equals mx plus b, where b is the starting amount and m is how things are changing. So we've got y equals change. What are we talking? What's changing in this problem? What's changing is how far away from her house she is. She's getting further from her house. So how does she change? How does that change? She's traveling 22 miles per hour. That's every hour you get an extra 22 miles. So 22 miles per hour. And that might be worth noting on here. That's 22 miles per hour. And then we're going to add to that the starting point. Where did she start? She started 3 miles from her house. So what does the other variable represent? The y. Well, we're talking about how far she is from her house, so this is the total distance from her house. And now we can use this equation to answer some questions. For example, if we want to answer the question, how far away from her house is she after 2.3 hours, that 2.3 is hours, and we know hours is the x. So same equation, y equals 22 times 2.3 plus 3. And that's going to tell us y, or the number of hours, the amount of distance she is from her house. Probably need a calculator for 22 times 2.3. That's 50.6. Plus 3. So she is 53.6 miles from her house after 2.3 hours. Her goal is to ride a century, 100 miles. So how long until she is 100 miles from her house? Well, that miles is her distance, so that's going to get plugged into the y. So the y is 100 equals 22x plus 3. And this gives us an equation which we should be very comfortable solving. Subtract 3 from both sides, and we get 97 equals 22x. Divide both sides by 22. And x equals technically the fraction 97 over 22, but you don't really talk about 97 over 22 hours. So let's get a decimal approximation. 97 divided by 22 on the calculator is about 4.41 hours. After about 4.41 hours, she will be 100 miles from her house. So that's all there really is to these applications of these linear equations, these story problems. We've got a change and a start. Where do you start? How much is it changing by? If you keep that in mind, y equals mx plus b, y equals the change times x plus the starting amount, you can model several different situations with a linear equation. Hopefully that'll get you started on your homework and applying those linear equations. Good luck on it. Let your instructor know if you have any questions.